Hello, this is Christopherson and this is my car wash project. To begin, I'm going to cover my project proposal and planning. Here you can see my project description as well as my project plan. This project consists of creating a program to run the car wash in 3 different modes, as well as having a jog feature, and then all of that will be able to be accessed through an HMI. The project's goals for this is to properly set up all sensors and use them in the program, and as well as having multiple levels of difficulty for the washes. Other goals for this include wiring the system correctly and having that system be fault tolerant in any situation. Now I'm going to cover my parts used in IO map. Here you can see my parts list. This has the part and other specifications. Here is my inputs. Here is my outputs. And here is the timers that I used in my program. Here is my bill of materials. On this you can see the part, the number, the quantity that I use, and the price, as well as a link to that part and a picture of it. The total price comes out to just under $6,000. And here you can see my materials such as wire and terminals. Here is my conceptual drawing. On the top you can see all of my controls, and on the bottom you can see the actual car wash. This car wash consists of 5 stations. It'll have the wash, soap, rinse, wax, and dry station. Each station has a sensor on it, and that will be used to tell when the car is at that station. Now I'm going to cover my schematics and CAD drawing. Here is my whole CAD drawing. To begin, I'm going to cover my first input card. This is my IB8 card. This is where all my sensors will be connected. On this first input is my first sensor, and as you can see, the 1, which is the brown wire, will go to the 24 volt from the power supply. 2 will be unused, that is the white wire. 3 is the blue wire, and that will go to DC comm. And 4 will be black, and that will go to my PLC, and this is all the way down for each sensor. Now I'm going to move on to the OB8 output card. This is where all of my stations, lights, and the fans and green light will be connected. Here is my first station, lit 1. This is the 2 lights next to the wash station. This is the same for lit 1, 2, 3, and 4. The fan follows the same layout but has less terminals, and the green light is just straight up connected. All of the grounds are tied together and will go back to the safety, and when an e-stop is active, those will all be cut off. Onto the other input card. This is an IB4 card. The first input is used for safety. On this I'm using a normally open contact from each of the relays from the safety relay. The next 2 inputs are used for the start and stop button, and the last input is not used. Onto the safety relay. Here I will show the manufacturer's wiring diagram and the physical pinout. Now you can see that I put DC comm on the left, and on this A2 is directly connected, and on the right A1 is connected to 24 volt. X2 is connected through the black button to X1. S13 is connected to the open on the e-stop to S14. S21 through the closed on the e-stop to S22. 13, 23, and 33 are connected to power, and the 2 relays are connected to 14 and 24. Those will be K1 and K2 and will be used for safety back up here. Moving on to my power supply. Here you can see my disconnect from L1, and this will go to my power supply. Through that power supply I'll go through a fuse and out to all of my devices that require 24 volts DC. This will also go to every branch on this diagram that is listed. Here is the wiring for the speed controller. This will feed into my motor, which will run the conveyor. Finally, this is my last output card. This is an OW4 card and will be used to run control relay 3 and 4. These control relays will run the motor in forward if the control relay 3 is active, and it will run it in reverse if both control relays are active. Here is also some other diagrams including the sockets for the relays and the sensor. Here you can see the before pictures. You can see that there is random stuff all around the case and that nothing is connected. Here are the after pictures of my project. You can see that the blue wires are the 24 volts coming from the power supply and the red wires are my common. Finally, this is my network map. Here you can see that the SCADA network is brought in through the lab switch to my Ethernet switch on the car wash. This is then brought to my panel view and point IO. Okay, here is my car wash. At the bottom of the screen you can see the actual car wash. This is where a car will be, and it will be ran through each of the 5 stations with the conveyor. At the top of your screen you can see all of my wiring and all of my control devices, and in the middle there is the control box that has a start stop button with the e-stop and reset. To the left of that you can see my PanoView 600. This is a touchscreen that will run my HMI. From there the customer will be able to choose their wash, and the employee will be also able to monitor anything that they want. This can all be done on that touchscreen, but for this video I'm going to pull up a view of that I have running on my computer. Now I'm going to go over the basic operation for this car wash. To begin, you're going to want to log in as one of the 2 users, the first of which is employee, with the username being employee, and the password is just EMP. The employee will have the lowest security level of this project and will only be able to view the welcome page, display page, and alarms page. You can also see that this display will show who is currently logged in. Now I will log out and log back in as the owner. The owner's username is just owner with the password of own. The owner will have the highest security level and will be able to check the money page and change the set points on the set point page. As you can see, now those buttons have shown. To begin operation, you can start or stop the machine from the HMI or from the physical start-stop buttons as I am showing here. Normal operation will begin by starting the machine and then opening up the welcome page. From here, the customer will be able to choose any of the washes, but you will not be able to choose a wash if there is no car present at the first sensor. So now I will go ahead and put a car at the sensor, and they'll be able to choose a wash. If the customer does not want the wash that they choose, they can click cancel and choose a different wash. So here I'm going to run the quick rinse, and once they choose that, you're going to click continue and then click that button to begin the wash. The wash will begin, and then the car will go through the process of that wash. For quick rinse, they will get 3 seconds of wash, 2 seconds of soap, 1 second of rinse, and then 5 seconds of dry. Now that the car is exiting, it will go all the way back to the start to simulate a new car pulling up. Now we'll go over the basic wash. Basic wash will get 5 seconds at each station except 10 seconds for dry. I'll put it into 2-speed here to speed things up. As you can see, the green light will flash when the car is currently getting washed and will be solid when a car is ready to be washed. Now you can see as the car is exiting, it will go back to the first sensor, simulating a new car pulling up. They will be prompted to click anywhere to begin a new wash. They will do that, choose their wash, click continue, and then they will click anywhere to begin. The car wash will now be running in the deep clean, and in this mode it will get 7.5 seconds at each station and then 10 seconds of dry. Now you can see that the deep clean is done. So I'm going to click this hidden button in the top left corner to return back to the employee page. And from here you can click on the money made, and this will show the wash is completed and the total amount of money made. You can reset this by clicking the reset count, and then that will reset everything to 0. You can also go on here and change all the set points by going to the set points page. All you have to do is click on the number and change it, but be cautious, the numbers are shown in milliseconds. Now I'm going to simulate stopping and e-stopping. To do this, I'm going to put the machine in normal operation by starting it, and then going to the welcome page and choosing any wash. I chose the quick rinse. Now I'm going to click to begin and let the car wash run normally. The stop button will only be able to be pressed by the employee, so here I will come in simulating and press it. Now a pop-up will show that the machine has stopped, asking the car to please exit. Once they exit, the employee will be able to come back in and start the machine and let it be ready for another car to get washed. Now I'm going to go and show the e-stop. I'm going to go back in, choose any wash, and then I'm going to click begin and let it run for a while. The e-stop will be able to press by anybody in case of an emergency. Here I come, I'll press it now, and a pop-up will show that emergency and the car is automatically exiting. A pop-up for the alarm will also show. Now I'll go back to the employee page, and you can see that the e-stop and alarm active bit are true. I'll go into the alarm page and acknowledge this alarm. I can also clear it or acknowledge all, but now you can see that the e-stop is still true and alarm active is true. I can't press the alarm active and get it to reset if the e-stop is still true. So I must go in first and reset the e-stop. Now that the e-stop is false, it will show that on the bit, and I can come in, reset the alarm, and now it is back to normal. Now I'm going to show an e-stop in the first station. Now start, and then right at the first station I'll stop it right away, and it does the same thing and works normally. Now I'm going to cover jogging. To enter jog mode, the user must hold the start button either on the HMI or the physical start button for 5 seconds. This will put it in jog mode, and you'll be able to tell if it's in jog mode by looking at the indicator on the right. The jog button will also pop up. To begin jog mode, you must choose a wash, and then you can click the jog button to jog it to the next station. The jog button will only be visible when it is at a station and ready to be jogged to the next station. I will also simulate an alarm here. I will let the dry station run for longer than 15 seconds, which is the preset for the dryer alarm timer. So once it runs longer than 15 seconds, an alarm will show up on my screen. That alarm has now showed up, and you can go and view it in the alarms page. Here you can acknowledge it, acknowledge all, or clear all. I'm going to go in and clear it, and go back and jog once again to get the car back to the exit. Now once it reaches the exit, it will take it out of any current wash that is in, and you'll go to the welcome page and choose a different wash. Now I'm going to jog it in basic wash. As you can see, the display page says that the machine is stopped. This is because it is not in basic operation. Now I will go back to the welcome page, choose deep clean, and jog it in that as well. Now I'll go back to the welcome page, see nothing is selected anymore. And now I'll go back to deep clean, run it for a little bit, and now I'm going to show an e-stop in jog mode. It runs normal just like the other ones and will show the same pop-ups as before. Now I can go into the alarms page after I clear the e-stop. I can go in, clear or acknowledge any alarms I wish, and then I can go in and reset that alarm preset. The alarms page has alarms for each of the stations. It is preset as if any station runs for longer than 15 seconds, an alarm for that station will occur. Now to exit jog mode, I must hold the physical or HMI start button for 5 seconds, and this will take it out of jog mode and hide the jog button. Finally, this is my user manual. In this you can find more in-depth detail over what I just covered and what each screen on the HMI does. Okay, now I'm going to cover the PLC program. To begin, I'm going to cover the main routine. In this routine is the machine started and e-stop bits. These will be used throughout the program. There is also the control logic for the green light, which will flash or be solid, and there's also all of the jump routines and a timer that will also be used throughout the program. Now I'm going to move on to the quick rinse routine. In this routine, this will be all of the logic for the quick rinse. So to begin, you're going to want to get your quick rinse picked. From that, you'll get the quick rinse active, and then you will follow all of your controls for getting it to run in normal or jog mode. Down here is all of the timers for each station and the logic associated with that, as well as logic to get the conveyors running whenever they are called for. Now on to the basic wash. This is basically follows the same guidelines as the quick rinse, other than it has a wax station. And deep clean is basically the same as basic wash, although the timers are just changed. On to the conveyor subroutine. Here is all of the bits that will tell the control relays that run the conveyor to be on. And onto the lights and dryers. Here is where all of the bits that will call for each station to be on. These will all control those direct outputs. And onto the jog subroutine. Here is how you get into jog mode. You have the timers to get it on and turn it off, and the main counter that will be used throughout the other program. Now onto the HMI section. These are bits that were primarily used within the HMI, but also are used within other parts of the program. Some examples of what are in here are the moving and exiting bits for the display page, as well as all of the counters for the money page that will count the total amount of washes done. And it also contains all of the alarm timers that are used within the alarm page. It also has the alarm present bit on it, which can be controlled at the alarm page as well. On to my project summary. What went well? I was able to create a very accurate wiring diagram which allowed my project and wiring to go very smoothly. I also feel that I did a good job with the safety relay, and managing my time could have been better, which leads into needs improvement. I felt that I spent too long researching devices, and I kind of found myself getting stuck in some spots. I also feel I could have spent a little bit less time on the HMI, but I feel that time was put to good use, and very happy with how the HMI came out. In summary, I thought this project was going to be easy at first, but I found out there was difficult tasks within it, and I am very happy with how the final product turned out.